Okay, we will be doing same direction problems now. I'm going to go ahead and choose 3 problems to do, and then I'll leave the other 3 for you to do. Okay, so we're going to do number 1. It says, a cyclist wearing a yellow helmet is riding at 21 miles per hour, leaves town. 4 hours later, another cyclist wearing a blue helmet leaves from the same starting point, traveling in the same direction at an average of 33 miles per hour. How long did it take the second cyclist to catch up with the first cyclist? Okay, so now let's go ahead and fill in our charts. We have a guy that's a yellow helmet. That's how we're going to distinguish on. One is wearing a yellow helmet, and another guy is wearing a blue helmet, or cyclist girl guy. It says a cyclist wearing a yellow helmet. Story. So this yellow helmet, he rides at 21 miles per hour. So for the yellow helmet, his rate, how fast he's traveling, is 21 miles per hour. Okay, then we've got the one that's wearing the blue helmet leaves, so there's a blue helmet, he leaves the same starting point, traveling at the same direction at a rate of 33 miles per hour. So he's going in the same direction. So they're both going in the same direction this way, and then 4 hours later, he's going to start off and he's going to go the same direction. Okay? Alright, and that guy, it says he's traveling at 33 miles per hour. So that's the blue helmet guy's rate. Okay, now we want to find out how long it took the second cyclist to catch up with the first. So that's our question. How long? So we're looking at time. Alright, so this is how you're going to do this. I like to put down who started first. Whoever started first, I'm going to let that be my variable, my t. Okay, and the yellow helmet guy started first. The second guy, he left how long after? He left 4 hours later. So what I like to do is my first guy left, he's my t, my variable, and then the blue helmet guy, he left 4 hours. So we're going to take 4 hours away from the t, because that's when he left. He left 4 hours later, so we're going to make it a subtraction problem. Okay, so now we've got our 2 key components of our table. Again, it's multiplication. This rate times time is equal to distance. And we got a quantity here, so I'll put my parentheses around it. We've got 33 times t minus 4, because he left 4 hours later. And now on same direction problems, you're going to set these 2 boxes equal to each other. So we've got 21t is equal to, because they're going the same distance, 33 times t minus 4. And now we're just going to go through and we're going to solve. So I'm going to keep my 21t, and then I'm going to keep my equal sign, and I'm going to do distributive property. 33 times t is 33t. 33 times negative 4 was going to be a negative 32. Okay, next step, I'm going to go ahead and subtract my 33 from both sides, 33t from both sides. Alright, and I'm going to move it over. I've still got my negative 132 on this side of the equal sign. And then 33 minus 21, I get 12t, and it's going to be a negative 12. Divide by negative 12, divide by negative 12. 2 negatives make a positive. 12 will go into 132 one time, 1 left over, and it's 11. Okay, so now we've got some information. We found out our t. Our t is the time, so t is the time of the yellow cyclist, yellow helmet cyclist. That's what we found, 11. But what does the question ask us? It asks us how long did the second cyclist take, the yellow helmet, or the blue helmet guy. So how do I do that? I take my 11 and I minus 4, because 11 is the first, the yellow helmet guy. We wanted to find out about the blue helmet guy, the guy that started second. So it's 11 minus 4, which is 7. It took our blue helmet guy 7 hours to catch up. Okay, that's the first one. Okay, let's go down. Let's do number, I think I said let's do number 3. Okay, so it says, a little hard to read, so I'll read it to you. It says, somebody's name here, I'm not sure what it is. Oh, Jamal, I think it is. Left home and was driving to his brother's house in Colorado at an average speed of 45 miles per hour. 1 hour later, his sister left the same house and traveled at an average of 54 miles per hour to catch up with him. She traveled by the same road as Jamal. How long did it take her to catch up? Okay, so again, we're going to fill in our chart. We got Jamal, and we have his sister. Looking at the information, they left Colorado and at a rate of 45, so that's Jamal's rate. Okay, so we're going to put 45 miles an hour, that's what he was traveling. Then his sister left 1 hour later, and she was traveling at a rate of 54 miles per hour. Okay, who left first? Jamal, so that's what I'm going to give the T to for time. She left how much later? 1 hour, so it's going to be T minus 1. Okay, just like the other same direction problems are going to be set equal to each other. So we have 45T is equal to 54, and now we've got our quantity, so we're going to put parentheses here, T minus 1. Okay, so now we've got 45T is equal to 54 times T minus 1. So we have our 45T is equal to 54T, because I'm using distributive property, minus 54, because positive and negative is a negative 54. Subtract 54 from both sides, or 54T from both sides. We have a negative 54, and then we ended up with 54 minus 45 is 9T, and it's negative 9T. So we're going to divide by negative 9, divide by negative 9. So my T is going to be equal to positive 6. Okay, what did I just find out? I found out Jamal's time. So T is Jamal's time. But what was my question asking me? My question asked me how long did it take her to catch up, meaning his sister. And so we're going to take 6 minus 1, which is 5. It took his sister 5 hours to catch up with Jamal. Okay, one last one. Hopefully by then you're going to have got it. You probably have got it by now. Okay, we're going to do number 6. It says a man on a bicycle averages 10 miles per hour riding down the road. A car leaves from the same point 2 hours later, traveling at a rate of 50 miles per hour. How many miles down the road will the car pass the cyclist? Okay, so here we go. We've got the bike, He left on a bike, a cyclist, and we have a car. So a man on a bicycle averages 10 miles per hour. So his rate on the bike was 10 miles an hour. A car leaves from the same point 2 hours later, we need that, at a rate of 50 miles per hour. Okay, and then it says how many miles down the road will the car pass the cyclist? So how many miles down the road? That's our question. All right, who left first? The bike. That's going to be our T. How long later did the car leave? 2 hours. That's going to be our T minus 2. Same thing, we're going to multiply. So we have 10 times T, and then we have 50 times T minus 2. Remember, same direction, these are always equal to each other. So we have 10T is equal to 50 times T minus 2. We have 10T is equal to 50T minus 100, because we're doing distributive property. Alright, numbers on one side, letters on the other, so I'm going to go ahead and subtract. Oop, that should be 100, sorry, instead of 10. Okay, we're going to subtract 50T from this side. We're going to subtract 50T from this side. We get negative 40T over here. And we get a negative 100 over here. Divide by negative 40 both sides. Negative and negative is positive. Okay, I can get rid of one of these zeros. So now I have 10 over 4, and I can simplify that to 2. 4 will go into 10 2 times with 2 left over, which can be simplified as 2 and a half. Okay, so I found out the time it took the bicyclist. It took him 2.5 hours. And then if I want to find out the time for the car, you take 2 and 1/2, you minus 2, and you're going to have 1/2 left. So it took him a half hour. Okay, does that answer the question yet? It says how many miles. We need to find distance. Okay, so I can take 10 and I can multiply that by 2.5, or I can make 2.5 into an improper fraction. So 2 times 2 is 4, plus 1 more is 5. 5 over 2. There's other ways you can do it. You can put it in a decimal or whatever you want to do. I can now cross cancel. 5 times 2 is 10. Hold on, what did I do? I know what I did. I made a mistake right here. Knew there was something wrong. Okay, so again, you can make these into decimals, or you can make it an improper fraction. I'll go ahead and finish with what I was starting. I know what I did. Okay, so I got 10, and I'm making this into 5 over 2. I'm going to cross cancel. 2 will go into 2 once, 2 will go into 10 5 times, not 2 times. 5 times 5, 25. So it took them 25 miles to catch up with each other, to pass the cyclist. Or you can take 1/2 of 50 is 25. Okay. Alright, so that is the same direction problems.